So I'm just going to start a timer so I don't run out of time. So finding, getting, and publishing CVEs. Bluntly, what is a CV and why do people keep bugging me about them? So this is the one slide I have to read from. I apologize. So do you remember those flaws in Intel CPUs? Who here has had to deal with flaws in Intel CPUs recently? Okay, so we've got Spectre, Meltdown, Foreshadow. How many am I forgetting about? Yes, correct. And so who remembers the one that broke ASLR via MMU? Right, exactly. That's the most recent one, Foreshadow. So that is, actually no, sorry, that's last year's one, CVE 2017-5925. And hands up if anybody knows whether or not it got fixed. No, it did not get fixed. Not by the CPU vendors. So basically, there's CVE 2017-5926, 5927, 5928 for the, and 5928 for the browsers. So the browsers fixed it by, remember they took away our high accuracy timing functionality? So yeah, so basically, who fixed that? Well, for example, if you look at SUSE's page on their CV, they marked it won't fix, as did many vendors, because quite frankly, ASLR is broken. So we've given up on it. But the point of this is without CVEs, looking up this information becomes nigh impossible. Whereas with the CVE, you have a lovely screen like this saying the description, you know, page table locks, blah, 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 boring. But more importantly, those links at the bottom. So if you click on them, you end up at a, this is the ANC, so this is the original project page and a little snippet from it where they talk about, you know, some processor vendors agreed with our findings that ASLR is no longer a viable security defense, at least for the browsers. Others did not dispute our findings. I love that. It's like, well, they didn't argue too much, so it must be real. From the browser vendors, most found our paper relevant and, you know, did something with it. And then so to track this, we have those 4 CVE numbers, right? One for Intel, one for AMD, one for ARM, and one for like all the browsers. And this is not an uncommon case, right? If you've dealt with Spectre or Meltdown or Foreshadow or whatever, you know, this is becoming more and more the common case, right? Everything's interlinked and interrelated and just a giant mess. So what's the source of truth for CV, right? A lot of people use CVEs. Who has the truth? Well, the answer is simple. It's the MITRE Corporation, and technically speaking, MITRE is a non-profit entity that isn't the US government, it's just they get all their funding from the US government. It's about $4 billion a year, and they run a bunch of projects for the US government, including a bunch of cybersecurity projects like the CV program. So they ultimately hold the true source of truth for CV, and that would be at cve.mitre.org. And then there's a bunch of people who republish it. Probably the one most of you use, and that I use, is the National Vulnerability Database, right? Hands up who knows the NVD from NIST intimately, right? Everybody. The reason for that is simple, because NIST adds a whole bunch of useful information to make CV more palatable. They add the CVSS scoring, right? So on a scale of 0 to 10, how badly, you know, does this hurt? They add the CPE data, which is the product information. You know, is it the Linux kernel? Is it glibc? Is it, you know, which version of Windows is affected? And then there's a whole pile of people who republish stuff like cvedetails.org and all these other sites which, to put it bluntly, are not a source of truth in the sense of they're probably correct, they may not be. I don't know. You know, we don't track them, we don't make sure that they're correct. So I would say if you're dealing with CV, please go to either the MITRE CV database, which is the true truth. The NVD is very good, they pull from it. But one little dirty secret is, you know, the NVD really only cares about the stuff the US government cares about. That's literally what they're paid to care about. So when they do an analysis of a vulnerability, like to add the CVSS scoring, they will do that for Windows and Linux and, you know, large enterprise projects that the government uses. But, you know, for a PHP script thing, yeah, the US government doesn't care, most cases. So that data that you're kind of relying on the NVD to add may not be added soon, if ever, right? Because there's tens of thousands of CVs a year now. Well, just over 10,000, about 18,000 last year. And so, yeah, please go to the original source of truth. Start your investigation there to make sure that you're not, you know, I've seen some sites that republish CV data and they drop stuff or they add stuff that isn't correct. And that's even worse because then you chase down a rabbit hole only to find out that it has nothing to do with what you thought you were trying to deal with. So let's get to the meat of the talk. Finding a CVE. So how do we find a CVE? Actually, quick question. Has anybody here ever found a vulnerability or an exposure and gotten it a CVE? Oh, awesome. So that's the first thing, vulnerabilities and exposures. So vulnerabilities, we're all pretty familiar with vulnerabilities, right? We're talking remote code execution, or the attacker can escalate privilege, or the attacker can send a wonky ping packet to your server and your server tips over and dies, right? Vulnerabilities tend to be pretty clearly cut. Simply put, does the attacker do something bad? Yes or no, right? Do they do something they really shouldn't be allowed to do? I'm not going to bore you with actually how you find vulnerabilities because I'm sure most of you know how. As an aside, if you want to rack up a quick CVE count, just go through GitHub and search for terms like XSS or buffer overflow. People fix these things and label them as such, but they don't bother to get CVEs for them. So if you want to get a whole pile of CVEs to your name, literally that's the quickest way to do it. Now exposures. What's wrong with this picture? Are those key secret anymore? No, exactly. So exposures don't typically allow an attacker to get directly into a system or to directly escalate privileges. But like going back to my first example, ASLR, address stack layout randomization, we used to think was amazing because it made the exploit codes fail, right? Because you'd exploit a problem, overwrite a buffer, you'd push in your shell code, and you'd call it, and it wasn't there. And you couldn't find out where it went, right? Like it was just literally in some random place. And you could theoretically try and brute force it maybe, but that's not going to work. Well, yeah, as it turns out, ASLR, you can determine the layout of memory through a whole pile of attacks. Just search the CV database for the term ASLR bypass. And so, we've learned, for example, ASLR no longer works as well as we thought it did because there's all these exposure bugs where you can determine how is memory laid out. I've seen things where, database exposure of hashed passwords. Yeah, not always terrible, except when they're like just MD5, hashing them. And you can, everybody in here with a laptop can now brute force those, because you have a laptop. CV counting and inclusion rules. This is intentional. There's a lot of text. It's very detailed. But honestly, what it really boils down to is sort of a couple of main things. Number one for inclusion is currently we cover traditional software and hardware, so on premises, right? We don't yet officially cover CVEs for like services. That's coming. We're working on it. But basically the first thing is this something that a customer actually runs, that they acquire and run and can do something about, right? The second thing is this something we cover, right? Traditionally it meant enterprise software stuff the US government cares about, Microsoft, Linux, blah, blah, blah. Obviously that scope is expanding. There's a ton of IoT stuff coming out of China. Some of it's in my house. There's no CV coverage for that, and I try not to think about it. Because honestly, I can't do anything about it. So that's basically, do we cover this with CV or not? Then the second aspect of that, is there what's called a CV numbering authority? So Microsoft is a CNA, right? They cover Microsoft products. Red Hat covers Red Hat. Oracle covers Oracle. And then as far as counting goes, splitting and merging. So there's never just one vulnerability, right? Like anybody who's looked or dealt with computer bugs, there's never just one bug, right? Like if there's one bug, there's more bugs. It's like cockroaches or ants in your house, right? It's not like one little guy just happened to wander in from South America and took up. No, it's like you gotta tear down your walls and get all the bugs out. So this is a very common case where literally, like the Intel stuff's a great example because now that people know to look for these types of side channel attacks and all this wonky stuff, we're up to about, 15 or 20 of them now, right? And there's just gonna be another dozen every year. It's a fact of life now. So how do we split and merge these? The answer is really simple, is it basically, does it add value, right? So if you audit a PHP application, you're gonna find a pile of cross-site scripting vulnerabilities. because that's how PHP works, right? And so is there really any value in like, oh, you found 10 cross-site scripting vulnerabilities in this different parts of the PHP script, we're going to assign 10 CVs? Well, no, because ideally what will happen is you find 10 vulnerabilities, and then the next release fixes 10 vulnerabilities. Hopefully. Doesn't always happen. So ideally we merge all those vulnerabilities into one CV, we treat it as a package deal and move on. If you've ever looked at CVs, you'll see the phrase CVE so-and-so, blah, 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 is assigned as an incomplete fix for this other CV, right? So what'll happen is somebody will find, myself speaking, I found 13 flaws, temporary file creation flaws in a piece of software. Told them they had to fix them. They said, yes, we'll fix them. They fixed 6. So good start. They released an update saying, we fixed all the 10 flaws. And I'm like, really, did you? And I checked, and of course, they fixed 6. So I assigned a second CV saying, there's still 7 remaining. Can you guys please fix them for real this time? And they're like, oh, we promise. Yes, we will. They released an update saying, yes, we fixed them. All of them. We promise. And I'm like, I checked the code. There's still 3. I'm like, okay, well, we're almost there. Like, this is progress, right? Third time's a charm. And they got all the remaining 3, right? But as a customer using that software, well, which version actually has all of these things fixed? So it simply boils down to we bucket up the CVEs so that each class of vulnerability, so if you have like cross-site scripting and a buffer overflow, yeah, those are very different impacts, very different exploit models. So it makes sense to split them, right? Because as a company, chances are you'd be like XSS, whatever, the web thing deals with that. We got some magic Cisco appliance that claims to magically deal with this, and it probably does. But the buffer overflow, ooh, that's bad. That's a bad guy getting in and taking over our server. And the second main bucket we do, which version is affected, right? If you have, my favorite is the Linux kernel, oh, we found a flaw in it. Well, what versions does it affect? Oh, it affects these versions. Oh, and while we were looking, we found this other related flaw, but it affects a different set of versions because, that code was added 6 months later or whatever, right? So it becomes very important when you're tracking this stuff, especially, in the enterprise world, to know, like, which versions actually fix this stuff. So that's splitting and merging in a nutshell. So let's make a CV. First question, when should you ask for a CV for your vulnerability? And the simple answer is, as soon as possible, please. Because it makes talking about it and tracking it so much easier. This is public now. So I don't know if anybody remembers the glibc stackguard stuff from, 2 years ago, I want to say, or a year ago? Anyways, Qualys did some really good research, found a flaw in glibc's stackguard page, right? So the idea is you have this 1 megabyte stackguard page, which if the attacker touches, we know something bad happened and we stop them. Awesome. They found you could literally jump over it. Okay, cool. And they came with a proposed solution and everything was awesome. Until one of our really smart guys, Florian Weimar, looked at it and he went, no, their problem is wrong because there's actually 3 problems. And their solution is wrong because we'll have to make the stackguard page 3.5 gigabytes per process for it to work. And, oh yeah, did I mention we now have, actually I found 2 more problems, right? So now we have 3 problems. So talking about these problems, when I say like, oh, the Qualys stackguard thing, the one that they found originally, no, maybe, or was it, no, it's the second one that Florian found and mentioned, it becomes impossible to have a meaningful conversation. Whereas CVE 2016, 1234, and 1235, and 1236, right? They're scoped, they're defined, we can talk about what we're talking about. So basically, like babies, please put a CV number on it as soon as possible, especially if the vulnerability is not yet public, right? If it's an embargoed or private vulnerability still, and you have to talk to other people, it's so much easier when you have a CV, because literally we all know what we're talking about. And most people have to handle more than one security flaw at a time, right? Like a vendor like Red Hat, I left in June, but essentially the trend was Red Hat product security was handling roughly 3,000 vulnerabilities a year. Yeah, so we're handling a lot of vulnerabilities. A company like Microsoft is around 1,000. If you look at even some of these open source projects, they have hundreds of vulnerabilities per year because just the size and scope of what they build, it's complicated and there's flaws. So please, I can't stress enough, ask sooner rather than later. The second step is, does the CV already exist, right? I've had a lot of people ask for a CV for something where we already have a CV for that. The challenge there obviously is if we have duplicate CVE entries, it makes a mess. The good news is I convinced MITRE to move all of the data into GitHub. Now it's in Git, and we can update it. So that's the one dirty little secret. The old MITRE CV database had no update mechanism, right? Every entry had some data, but there was like no field to specify that like this has been updated on this date, right? So I actually at one point had like manual tools that would download the database every hour, compare it to the previous version, and show me the differences, like what was added, what was deleted, what is new, whatever, right? So now that we're in GitHub, obviously if you're familiar with Git, it's really, really easy to look at a file or a set of data in Git and be like, what has changed since Thursday? Or has it changed at all? If you're getting a CVE, who is in charge of that software? So as I was saying, scope. So the idea of scope is a company like Microsoft, in theory, knows their software the best and can best handle and assign the CV for that security issue, right? Same thing ideally with Red Hat or with Oracle or with whomever. So the basic premise of when you find a CVE in a piece of software that has a CV numbering authority in charge of it, you have to go to them first. And also, obviously, we want people to report the vulnerabilities to the vendors, to the projects, right? To the upstreams, so that they can get fixed, right? Who here has seen a security flaw talked about online and nobody told the project, right? That's sadly quite common with some things, right? So, I mean, I love people that find vulnerabilities. That is something that we need more people to do. But we also sort of need them to tell the people in charge of that software about it so that maybe they have a chance to fix it, right? Because, yeah, otherwise we're just kind of being jerks. So right now, there's a CNA scope document that's terrible because it says things like, for example, Airbus is a CV numbering authority, and Airbus covers all of their own products and all of their suppliers. Now, who here knows who Airbus's suppliers are? Nobody. Like, of course nobody knows who their suppliers are. Probably Airbus doesn't even know fully. So again, this is a project. We have a specific project called the CV User Registry, where the premise is everybody involved in the CV project will have to declare like who they are and what they cover. So like Red Hat, for example, when I left, there was 110 or 120 commercial products and 126 GitHub organizations that I managed to track down, right? So Red Hat has this huge footprint of stuff. Same thing with Microsoft, right? Who here has heard of Great Plains Software? Well, Microsoft bought them like apparently 10 or 20 years ago. I literally had no idea. Or I remember once I was looking at Snort and I'm like, why does the Snort page say Cisco now? Like what? Oh, wait, what happened? So ideally we're gonna have a registry with URLs of the products, with the names of products so that you can easily take a piece of software and go like, who's in charge of this? And if there is somebody in charge of it, you'll be able to figure it out in a few seconds. And if not, we have what are called the CNAs of last resort. So it's a scoping thing that I'll get into in a sec. But simply, what is the minimum CV entry? Does anybody offhand know? Well, it's what you literally saw on that previous screen. It's literally, you have to have a CV ID. You have to have a product name and version. Obviously, right? We got to know what we're talking about. You have to specify a problem type, which is not entirely true. There's a lot of CVs in the CV database. I don't know if you've looked at Oracle stuff, for example, where an unknown flaw with unknown impact, exploitable through unknown means has this terrible effect. Like, thank you, Oracle. And I mean, in fairness, what are you going to do? Either you apply the patch or you don't, right? Like, there's really not a lot you can do with some vendors. So ideally, there's a problem type, buffer overflow, cross-site scripting, temporary file, whatever. There's that text-based description, which doesn't have to, but also, again, ideally, also includes like an impact. Does this result in code execution? Does it result in the server catching fire? Does it result in, whatever? And then the references, which is the URLs, which, if you've ever had to investigate a CVE, those are the gold, right? That's what you want, right, is those references so you can go spider out and start looking at stuff. And then finally, of course, it needs an assigning CNA. Like, who actually assigned the CVE, right? Like, they just can't appear out of nowhere. So currently, we're working on federating the CVE hierarchy. If you look at it currently, it looks like this. It's MITRE, everybody. Like, it's a flat structure completely, right? What we want to move to is where we have the primary CNA, which would be MITRE probably. And then, for example, we're hoping that JP cert, Japan cert, will take over the Japanese market because they speak Japanese and they live in the same time zone, right? For anybody who's had to deal with people in like Asia Pac, you know that the time zone thing is a huge problem. And the language and culture thing is very different, right? Like, I come from the open source world, and the way open source handles security, I can guarantee you, would not fly at all in Japan, right? Like, they just could not, culturally, that would be a no-go. Same thing for aerospace, right? Aerospace isn't gonna be like, oh, sure, yeah, whatever, publish the details, it's fine, yeah, we'll fix it later, right? They're gonna get sued. Same thing with pharmaceuticals and medical. Who here remembers the whole St. Jude's pacemaker debacle, right? Somebody claims they found a flaw. The pacemaker company came out really hard saying, no, you didn't. Well, turns out they did find flaws that were really, really bad. So the idea is we'll have these hierarchies. We have one for open source right now. And longer term, we're hoping to have like IoT, medical devices, aerospace, also geographic ones, because like I said, sometimes I don't speak Mandarin or Cantonese. And we've dealt with people there where they don't speak English, right? I mean, and so like Google Translate is great and all, but not that great. So this is something we're working on. Sadly, this guy has more automation than we do. The current CV, you're gonna see, I'm gonna live assign a CV, and you're gonna see the horrifyingly manual process that we have, or that I have. And most companies don't have anything that much better. But yeah, right now publishing to the CV database looks basically like you hand it off to a CV numbering authority and hope they do the right thing. And in some cases, that's me, and I apologize. I'm terrible. Again, we're working on automation. I got them to put this thing in GitHub. So at least now the data, you can get a read copy of it very easily. And longer term, we will be granting more people access to write to the data, which is something we just didn't have in the past. And if anybody here has been doing CVs for more than 10 years, you'll remember there was a really bad period between about 10 and 6 years ago where getting CVs and getting them published took forever. And the reason was simple. Like, MITRE lost a bunch of their funding. They had like 1 or 2 guys working on it. So yeah, that's what happens. When you have 1 or 2 guys working on a project, it gets slow. And stuff would just disappear into the MITRE hole, right? You'd send them a CV request and it's gone for like 3 months or a year, whatever, who knows. At least now that it's in GitHub, you can sort of see what's going on to a degree. So finally, publishing your CV to the world. So number 1, get your CV as early as possible. Number 2, use it. Ideally, in a perfect world, put it in the Git commit. Now, realistically, a lot of people find and fix security flaws very quickly, or sometimes they fix a flaw, don't realize it's a flaw, and then somebody else comes along and goes, hey, that code commit you committed is really awesome because it fixes a security flaw. And you're like, what? Oh, yay, I think. I'm not sure, is that good? But publishing it as soon as possible and using it widely makes life so much simpler, right? If you have the CV and the change log, the release notes, in the documentation, in your database, whatever, it just makes it so much easier, especially now that with open source, it's not like it affects one person, right? Something like the Linux kernel, glibc, OpenSSL, right? Everybody ships that, right? OpenSSL is a great example. How many of us own a TV? Okay, you all have OpenSSL in your TV, right? Because all the other SSL implementations cost money. So when you build a TV and you need to put SSL and TLS into it, which you have to do now because it needs to be able to do Skype and Roku and Netflix and all that other stuff, it has to have an SSL TLS client. Well, are you going to pay money for it or use OpenSSL? Well, everybody uses OpenSSL. Same thing with cars. So, demo of a CVE assignment. So basically, I run the Distributed Weakness Filing Project, which is a fancy way of saying open source CVEs. It's a holdover from my work at Red Hat. So, I actually forgot to pull up that page. So literally, if you want to get a CVE for open source, and it's not covered by a Cname, so for example, there is, Red Hat's a CNA, they cover their open source stuff. Kubernetes is a CNA, they cover Kubernetes. But if there's not a specific CV numbering authority for that software, go to iwantacve.org. And you'll see this form, and I ask things like, oh, that's terribly small, sorry. Oh, nope. But you'll basically see I ask for things like, is this open source? I've actually had people request stuff for not open source, and I'm like, I can't help you, sorry. And then I'll ask you for things like, what's the name of the product? Who's the vendor? What version is affected? Like, do you know? Please tell me you know, because if you don't know, then we kind of have a problem. What is the vulnerability? A lot of people, they'll find a problem like, oh, I made the program crash. Cool, good for you. Is it reproducible? Is it something actually bad? If you can make, I remember it was a piece of software that turned a specific file format for sheet music into PDF files, right? So you could like write up a score and then turn it into a PDF and print it. Nice. And you could make it crash with like a wonky file. Cool. The response from the CV community is like, don't do that. Like, don't open that file again. If you open a file in that program and it crashes, well, just stop doing that. Versus, let's say, a web browser. Now, should a web browser be able to open literally any web page full of God knows what and not crash? And the answer is yes, right? That is an expected behavior. Should you be able to open an email no matter how badly formatted and your email client doesn't like go nuts? Well, yeah, right? That's expected behavior. So I basically ask for a bunch of information, and it gets chucked into a spreadsheet that literally looks like this. It's a bit out of order, but basically there's the timestamp, there's who requested it, right? There's the vendor, the project, the URL of the product, because I want to, sometimes I have to go check and make sure it's actually open source. And I'm flexible that way. Like if it's OSI licensed, for sure, cool. In other cases, whatever, close enough is close enough, right? What's the vulnerability type, right? As we can see there's a nice selection of different vulnerabilities. What's the affected component, right? Like, have you actually narrowed it down a bit? And in some cases, as you can see, they haven't. They're just like, whatever, the whole thing, it's affected. What's the impact of exploitation, right? Again, if you can't clearly articulate and say, I did X which caused Y, and Y is bad because, then maybe it's not really a security flaw, right? But most security flaws, like 99.8% of them, are really simple. Like, I made it crash, I made it do what I wanted to do with code execution, I read your password. Like, it's not rocket science. Ideally an attack vector, because again, if I remember some PHP apps where they're like, oh, if you're the admin, you can do a cross-site scripting vulnerability by putting up these custom web pages. And I'm like, yeah, that sounds about right. That seems reasonable. And in other cases, they explicitly say, no, the admin is only supposed to be able to administer users, not do this, that, and the other thing. Oh, okay, that's a flaw, as defined by your sort of security profile. Then I ask for references, and this is always lovely because some people have a habit of putting stuff into YouTube videos and sending that. Which sucks because I have to watch a YouTube video that's really badly made and you can barely read the text, but I can't cut and paste and it's not accessible. And that's something, as I get older, I'm beginning to realize accessibility matters, right? We don't want to lock blind people out of the security community. That, I feel, would be kind of a jerk move. So one thing I'm pushing for is some form of a rule that will say, when you submit data for CVEs, like reference URLs, I don't know exactly what the rule will say, but something like you have to be able to cut and paste it, or you have to be able, you know what I mean? It can't just be like a screenshot of a PDF of text. Again, I've had people send that. Ideally more than one reference URL. And then there's my stuff, my notes, and how terrible this is. And as you can see, there's a bunch of stuff I've rejected. One request there at the top, it lacks a request URL, and Jeremy sent me a new one. But here's this week's my favorite request. So this guy sent me a request for Python software, and one thing I've noticed is when it comes to people claiming flaws in big projects like Python, they're either totally correct or totally nuts. This guy turns out totally correct. So he's like, hey, there's a flaw in Python, in CPython, which we all use and love, right? Python is awesome. And fixed version, after commit so-and-so. Oh my goodness, that's lovely. Vulnerability type, good Lord, he's actually got it there nicely. CWE 77, improper neutralization of special elements used in a command, also known as command injection. Like, we're on fire. Affected component, good, like, seriously, the shutil module make archive function, like he's narrowed it down. It's a denial of service and information, blah, blah, blah. You basically have to open up a malicious zip file, which, yeah, that's a pretty reasonable thing to do, right? A lot of data gets passed around as zip files and gets unpacked somewhere and turned into Lord knows what. And then he has these URLs, and he actually, for example, this is a good sign, a link to the official bug tracker. That's like, this is kind of the gold standard. Oh, that's tiny. This is kind of the gold standard, right? Because the beauty is not only is it in the bug tracker for the project, but then chances are, oh, look at that, they actually acknowledged it and fixed it. So at this point, I'm feeling comfortable that, you know, this guy is legit, and if you read it, you know, blah, blah, blah. It's not, I love this. Distutils spawn isn't very good at quoting command lines. And then he links to an older bug where they talk about this back in 2015 and never really fixed it. Awesome. So new change set, some big long number by Benjamin Peterson in branch 2.7, blah, 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 fixes this. Awesome. He also links us to the older bug. As you can see, 2015, and it's kind of like, yeah, whatever. It's hard to quote characters. They talk about it a bit, and then nothing really happens. That's quite common for sort of quasi-related security bugs that aren't clearly bad. Oh my goodness. Here's the actual commit, which as you can see is pretty simple, right? It's, yeah, they replaced the spawn with a sub-process check, and I don't know if you're familiar with Python, but Python kind of goes in that we wrote something that did something, we figured out it was terrible, so we wrote like a newer thing that we called something different and it does it much better, and then we found out that was terrible. And so like in Python, to open up a command line, you've got like, I want to say like 6 or 7 options, like different ways to do it. And as my current understanding is, sub-process is probably your best bet to do this securely and safely. Then we've got the link to the actual like issue in GitHub, which again, this is a good sign, right? This is all sort of, these are legitimate sources of information. It's not some random guy's webpage with like a PDF on it saying, I claim X, Y, and Z. And more to the point, you know, it's being acknowledged by the developers, right? I've literally had flaws where literally the flaw is like, I found a cross-site scripting vulnerability in your program. And the response from the developer is, yes, you did, thank you, we fixed it, awesome. And I'm like, oh, so easy to make that request. I've had other ones where they make some crazy claim and it's ignored. Or the admin goes, I don't think so, and closes it. And I'm like, you know, can you give us a hint maybe? Again, more GitHub stuff. And he even linked to a reproducer. Like, how nice is this person, right? They gave us a clear bug report. They linked to the official sources. They linked to the code commit that fixed it. They gave us the right versions, the names, and like, here's a reproducer. I'm like, I love this person, right? So, what do I do with that? Well, basically, I go to my little spreadsheet, and that entry is like now happy. So I move it into the assigned request tab, and then I give it a CV number. Literally, that's it. So there we go. I gave it CVE 2018 1,802. So I've given it a CV number, but I haven't yet published it, right? We probably should do that. So let's do that. Now, what I basically do is, and I don't usually do these one at a time. I do them like Friday afternoon at the end of the week, usually, and batch them up, right? And do it all in one big go. So, whoops, not that one, that one. Oh, good Lord, why is it so tiny? Tell me when you can, is that readable or bigger? Okay, well, I'm getting old too, and I abhor 10-point fonts when I'm watching stuff. So first thing I'm going to do is update my local copy of the CV list repo. How to explain this sanely? The MITRE Corporation moved the data into Git, but Git is not the true source of truth. The way they work is you submit your data to a branch of their Git repo. They then pull that data into their backend, which lives somewhere in like North Virginia, mangle it, manipulate it, put it into their database, and then they export their entire database back into the Git thing, like I think it's once an hour. So the Git repo is not the true source of truth. It's like people and stuff, the Git repo, the actual hidden backend. And that's just historical process, right? They've got this backend that they wrote in like 95, and that's that. So it's a bit of a cumbersome process because what it means is you cannot touch master. If you touch master, everything breaks. So we're not allowed to touch master. So I update all that stuff, and then I'm going to check my notes to make sure I'm not forgetting anything. Yeah. So first thing I'm going to do is, what I would normally do is I essentially reserve a CVE. Right, so there's a bunch of CVEs. Well, now number 802, is 802 free? Probably. Maybe I used it for an embargoed issue that isn't yet published. So what I do is I mark a CVE as reserved, and actually kind of the easiest way to do that will be take an existing reserved one and make a new reserved one. So basically CV 1,630,000 is reserved, and I just made a copy of it basically. So here we go. As you can see, a reserved CV is very simple. It's basically marked as taken, and like as reserved, and the value reserved, this candidate has been reserved, blah, blah, blah. Basically, it's going to be used at some point. So now, you know, I'm hopefully not going to double assign 802 because I almost never do that. Then I'm going to make a CVE. So that makes a big good. What is it? Nope. Yeah, what is the command? Sorry. Oh, so tiny. And I'm just going to skip the whole where I would normally commit that reserved CVE, put it into the database as reserved, and then later actually publish it. We'll just do it live because live demos are the best demos. So, whoops, no, that's the wrong directory. There we go. Boop. Okay, there we go. So what I discovered, most people aren't great at writing English, especially if it's like their second, third, or in some cases fourth language. So I used to ask people to write their own CV descriptions, and I discovered that that was not the way to go. So now I just ask for the data, and then I generate it. Let's open that in something more readable like Atom. So I basically machine generate it, literally using sentences with like variable replacement. Like it really is that simple. Oh, right. Okay, that's gonna mangle it. Hang on a second. Let me. There's a really sadly easy way to make this a bit more readable for you. This is my go-to when I need to like super quickly format a chunk of Json. And pew, 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 pew. Whoa. Where's my mouse? Okay, so as you can see, the format is reasonably simple, and of course it's out of order. So basically at the top we would have the metadata, right? This was assigned on today's date. It was requested, oh geez, a while ago. The ID, the assigner, me, the requester, this guy, I assume. Data format, MITRE, problem type, blah, blah, blah. Description, English. So we now support multiple languages, huzzah. Improper neutralization, blah, blah, blah. So, we scroll up, of course. You'll see things like, so we've got machine readable data now the dirty secret. Things like that product name and that vendor name are not standardized. I apologize. Something we're working on. So for example, when we have the Linux kernel, is it Linux kernel, the Linux kernel project? I don't know, but we basically need to pick one and stick to it, right? I think you would all agree with that. Scrolling up, there's the description written by a computer script. So Python Software Foundation, Python, CPython version 2.7 contains a blah, blah, blah. This attack, yeah. You know what? It's not the prettiest English, but it's readable. And then we've got our references, which, again, that's kind of often the more important stuff because that lets you research it and track it down. So, yeah, good enough. So we got a file, and I will just, here we go, find my note. Okay, so I need to make a branch, and whoops, what just happened there? Oh, whoops. So this will make the branch and then check it out. So I'm now working on a branch called DWF-today's date -01. I'm going to copy the JSON file here, git add it, right, 802, git commit, where did my mouse go? Oh, well, it's there. Now, public, whoops. Oop. It's thinking. And then I will commit it to that branch. Oop. And that exists now in my, so I have a copy of the CV list repo, so I have my own repo that I work on, and then I push my changes. And GitHub makes that quite wonderfully simple. Let's make this bigger. Oh, maybe you can't see that. Assuming this works. There we go. So compare and pull request. And I click create pull request. And that's it. Now what will happen is MITRE on their end will look at the pull request. They have a little bit of CI to make sure that the request is well formed, you know, that I haven't sent them some mangled JSON or whatever, right? There's all sorts of things that go wrong. Yeah, it's ridiculous sometimes. But anyways, they'll basically run through their CI test. They'll make sure it's like a signed git commit, right? We require signed commits so that we don't have random people dumping stuff in there. You know, we have a very strong factual evidence trail now of like who did what to which CVE when, which we didn't have before. So this is a bit of an improvement. But essentially, at some point, probably, what time is it on the East Coast? They've all gone home. So it'll probably happen tomorrow morning. They'll look at this, accept it, push it into the database. It'll get done on their back end. They'll push it back out into Git some hour at the top of the hour or whatever. They'll also publish it on the website, and it will exist. And that's it. A CV has been born. As you can see, we need automation. We need to do a whole lot of things, but if I told you what the situation was 5 years ago, you would cry and throw stuff at me. But like I said, we're working on this. And if you're not into like the whole US government news tracking, they're currently going through a kerfuffle because, for example, the CV project doesn't have reliable funding, right? They're on a project funding basis rather than like every year we're actually gonna probably give you money. It's like a very, maybe it happens, maybe it doesn't type of thing right now. So hopefully CV becomes a bit more healthy and a little bit more reliable because like I said, right now, it runs on a bunch of people, like most open source projects who like we're trying to do the right thing, but we also have lives and vacations and like get sick and stuff. We're trying to automate it. You know, we've got a bunch of projects around the CV User Registry. So who all is involved in this? How do you contact them, right? That's a huge problem, right? You find a vulnerability in something, how the heck do you get a hold of the person in charge of it, right? You go through, if anybody here has ever found a flaw in a corporate piece of software, who here has tried to talk to corporate frontline support about a security flaw and report it, right? Yeah, like take a shot. You know, it's misery, it's horrible. So we want to, have like Red Hat, very simple. You email secalert@redhat.com, and a human being reviews it. And we had some very tight SLAs on when we had to deal with it and when we had to reply. You know, and that reply might be like, thanks, but no. But at least a human being saw it, right? Like, there's other vendors where you email them stuff, and I don't know what happens to it. Like, good luck. That's all I can say. So yeah, that was the CV being born. So I guess with that, I'm basically, yeah, there we go, perfect. Oh, right on time. So the demo went well, thank goodness. How do I put this back into presenter view? There we go. And it's going to go to the front. Yeah, nope, good. So, quick question. So you want to be a CNA, a CV numbering authority. Right now in the open source world, so for example, we have Kubernetes is one. I'm currently minting a couple like Jenkins and I want to say PHP. But if you want to be a CV numbering authority for your software or project that you're involved in, I'm trying to make that easier. It's still very manual and a bad process. So I'm also looking for guinea pigs because I'm trying to streamline the process and find out sort of what's the minimum viable product. So one thing I realized, for example, is I don't necessarily actually need to train you on all the CV stuff. You can find what we're going to call as a CV mentor, somebody who knows CVEs and knows how to handle them. So you would basically go to them and say, I think I found a security flaw, let's do the CV song and dance, and they would help you do that. They'd help you bundle up the CV request, make it correct, like that Python request was, as you can see, very quick and easy to process, right? Because he linked to all the right information, used all the right words, it was all simple. So if anybody's interested in that, just please email me, either kurt@seifried.org or kseifried@cloudsecurityalliance.org. It's also on the iwanttocve.org webpage. But like I said, the more CNAs we have, the more distributed it becomes, the better coverage we have, and that's ultimately what we want, right? My back of the envelope calculations say we need about 1 to 10 million CVs a year, and that would give us good basic coverage of the open source world and like probably 10% of all commercial software that kind of matters. So in conclusion, the current CV system kind of works, mostly works. It's pretty good. We cover the big things. Microsoft does their stuff, Red Hat does their stuff, Oracle does their stuff. I don't agree with the way they do it, but at least they do it. It's better than before, where it was just like, literally vendors like Oracle would say like, here's a patch, install it by Tuesday, or else. Like literally, I've seen, back in the day, vendors would say things like that. And you'd be like, why do we need to install it by Tuesday? And they're like, no reason, just do it really quickly. And then you look at your calendar, you're like, oh, right, DEF CON starts Tuesday, right? Like literally, it was such a horrible situation. And again, I also come from a vendor in past, so I apologize. We haven't always made things as easy and as nice as we should have for our customers. So with that, I guess question and answers. Does anybody have any questions? And there was
I actually have a quick question. Do you want to tell us a little bit about your open source security podcast, a little plug?
Oh, sure. So myself and actually my former manager at Red Hat, Josh Bressers, we do a thing called the Open Source Security Podcast, where we talk about mostly security, quite often in an open source context. It's a opensourcesecuritypodcast.com. And it's a weekly, he releases it on Sunday. And like, for example, we recently did a review of Bruce Schneier's new book. Too long, didn't read. You probably know all of it, but he writes it in a way that is very approachable to normal people, which, that's something yesterday's, I guess, keynote was, how do we talk to normal people? Like most of us, myself included, is something we're working on.
Great, thank you. Any questions from the audience? Oh, yep. I'm going to try not to fall.
The situation with MITRE reminds me a lot of what the internet went through when it moved from NIST to ICANN and IETF and stuff like that. So is there any kind of push to say we need to get MITRE into its own sort of organization separate from the US government and not get its funding and be dependent on that?
So sort of. So fundamentally, MITRE is a nonprofit, and they do US government contract oversight. They have a couple mandates around security, biosecurity, cybersecurity, whatnot. What we're doing in CV world is right now, essentially, like if MITRE loses their funding from the DHS, the CV project basically dies, right? It's not, we don't have enough of a community yet. So, coming from the Red Hat world, what quite often happens is Red Hat wants to get these open source projects to grow up and stand on their own 2 feet. And that's where we currently are with CV is, we're basically trying to sort of decouple ourselves a bit from MITRE so that we're less reliant on them. So part of that is this federation, this hierarchy, which is just removing the actual day-to-day kind of CVE handling and management from them. From a governance point of view, we're also working on things to reduce sort of MITRE's involvement in the sense of, like right now they do most of the heavy lifting, right? And because that heavy lifting costs money. And like, I don't have a budget to do it, Red Hat, here, Red Hat did, that's where I used to work, and, I spent a lot of time working on CV on behalf of Red Hat, and Red Hat, Red Hat was responsible for, 15, 20% of the CV database in total, up until recently. So we need more of that open source model where the community stands on its own, but we're a long ways away from there with similar problems to most open source is that everybody wants to use CVE, very few people want to contribute to it, right? And it's great that people use it, and I want that, just like I want people to use open source, but at the end of the day, somebody has to do some programming or some CV assignments or, has to do some work. So these are things we're working on. And like I said, there's a current congressional kerfuffle about their funding where they're like, oh, you guys are doing a terrible job. And they're like, yeah, we kind of are because our funding keeps going away. Like, what do you want from us? So they recommended it become a line item. Like, we just fund this thing every year, right? Which will improve things vastly. So it's growing up, and part of it is, almost nobody knew about CV up until a few years ago, really. Like, it was a very niche thing, but now security is not a niche, right? We've created all this crap, plugged it into the internet, and discovered, whoops, now we need to update it. How do we track that, right? How bad is it? We don't know. So I'm thinking probably within 5 years, the CVE community will be able to largely stand on its own feet.
Okay, thanks.
Any other questions? Oh, yeah.
First of all, what does that mean to you?
I was curious about your position.
So I have probably 5 positions on that. So disclaimer, I worked for Red Hat at product security for 7 years. Prior to that, I worked for iSight and iDefense, which were vulnerability aggregation companies. So in a perfect world with spherical cows, people would do the right thing. Not just the people finding the vulnerabilities, but the people responsible for the software with the vulnerabilities. We don't live in that world. There's a lot of economic and market forces that basically say, haha, I sold you something and you, no backsies. Like, why would I support it? No backsies, right? I got your money. Sucks to be you. So, on the one hand, I wish every researcher responsibly took the time to go to the company, work with the company, within a reasonable time frame, get it fixed, blah, blah, blah. But there's just some evil companies out there. Or, last year, Ford and a couple large car companies actually came out and said, we won't sue you if you bring a security vulnerability to us. And I was like, oh, that's actually progress. Like, straight up, that's progress. No, there's a lot of industries, like in a lot of the world, if you find a flaw in your bank's website, what do? The correct answer is nothing. You don't tell them, right? Because the cops will show up and take all your stuff, right? So I would say, like many things, iterated prisoner's dilemma. Try to do the right thing. Please do the right thing. And if that doesn't work, to quote Troy Hunt, he talked last week about the value of public shaming of companies with bad security. Yeah, the reality is that's what you need to do to some companies. I would also say maybe look at the company's track record, right? Some companies might have a legitimate need to be like, oh God, that's going to take like 3 or 6 months, or a great example being this Intel stuff, right? Like, yeah, software, sure, we can fix that, but it's hardware now. And we need the hardware vendor, ultimately we need them to roll new silicon. We also need micro patches in the meantime, and we need the vendors to fix all their Linux kernels. And like many of these complicated problems, they start looking into it, and all of a sudden it goes from somebody proposed this problem with this solution. Turns out it's way worse than we thought. It's a million times more complicated. So we're going to need 6 months or a year, right? Everybody complains about how long Spectre and Meltdown were in private. Yeah, it had to be. There were so many engineers working on it, and so many people at so many companies dealing with this, and we still didn't do what I would say, we didn't do a great job. We did an okay job. Ideally what happens is with the stack guard flaw, we had it private for about, I think it was 5 months or something, and Florian found a whole can of worms and did a whole bunch of hardening and changes to glibc in addition to fixing the flaws. And then the day hit, we rolled out the updates, nothing happened, right? No press, everybody installed the updates and life went on. And ideally that's what happens, right? It's, all these tires might blow up or whatever. So just, go to the garage and get your tires swapped, boom, done. We're all good. So as far as responsible disclosure goes, like, yeah, I would encourage people to be nice, but fundamentally that doesn't always work. And also I would say, you know, protect yourself, right? Because some companies and organizations will come down on you like a bag of hammers if you give them bad news, which is unfortunate, but it is the world we live in.
Great. Well, thanks, Kurt. That's all the time we have for questions. Round of applause for Kurt.